Oh, dear students, firstly I will introduce myself. I myself, Professor Asset Chaube, working as assistant professor in electrical engineering department of SND College of Engineering and Research Center, Yola. So up till now, we are seeing the high voltages. We have seen the breakdown in gases. We have also seen the breakdown in liquids. Now the importance is going to be the now breakdown in the solid dielectrics. In the last lecture, I have told you that there is a complexity between the solid dielectric, so it is going to be very not easy to study the breakdown in the solid dielectric. So in the last lecture, we have seen the different theories that are going to be that is going to be causing or that is going to be reviewing the breakdown in the solid dielectrics. So when we have seen, firstly we have seen that different breakdown mechanism. We have seen in the last lecture what is the intrinsic breakdown. Right. In the intrinsic breakdown, again we have studied the electronics mechanism, and the second one is the avalanche mechanism. So in this lecture, we will see the remaining mechanism that is going to be causing, that is going to be due to what the breakdown in the solids. So firstly, that is going to be the electromechanical breakdown. So this happened due to the high electrical fields. When we are going to apply the high electrical field, the failure in the case of solid occur due to electrostatic compressive forces which can exceed the mechanical compressive strength. You know that every solid particles, every solid dielectric has certain mechanical strength or mechanical compressive strength. When these electrostatic compressive forces which are applied due to or which are due to the high electrical field are exceeding or more than mechanical compressive strength, then at this time the electromechanical breakdown in the case of solid dielectric. Remember that when the electrostatic forces or stresses that are coming due to high electrical field exceed the mechanical compressive strength, then at this time the electromechanical breakdown occurs in the case of breakdown in the solid. If the thickness of this specimen is D0 and is compressed to thickness D under an applied voltage V, the electrically developed compressive state is in equilibrium. When the electrically developed compressive space is in equilibrium, when the thickness of the specimen D0 and is compressed with thickness of D under an applied voltage V, then at this time compressive state is in equilibrium position. Now next one, thermal mechanism or thermal breakdown. We know that the dielectric strength of a solid dielectric increases with the thickness. More thickness, more dielectric strength. But this is applicable only for certain thickness. If the thickness is going to be above that one, above that specified value, then in this case, heat generated is dielectric due to flow of current, determining the conduction. It means if the thickness should be increased, because the dielectric strength of the solid part, solid dielectric increases with the thickness. But there is a limit. If this limit is crossed or the value is going to be above a certain thickness, then at this time heat generated in the dielectric due to flow of current determine the conduction. When the electrical field is applied to a dielectric, conduction current, however small it may be, flows through the material. Flows through the material. The current heats up the specimen and the temperature increases. Just I have told you that heat is generated, and due to this heat generated, the specimen is going to be heated, and due to this specimen is heated, surely you can say that temperature increases. And this heat generated is transferred to the surrounding medium by conduction through the solid dielectric and by radiation from its outer surfaces. And this is the case. But in this case also, when the equilibrium is reached, when only when the heat used to raise the temperature of the dielectric plus the heat radiated out equals the heat generated. When means the equilibrium is going to be reached, remember, heat used to raise the temperature of the dielectric plus the heat radiated out is equals to the heat generated. At this time, the equilibrium is reached in the case of solid dielectric. Now, next one, chemical and electrochemical deterioration and breakdown. What happened? Due to certain air or certain gases, that material goes certain chemical changes. It means the chemical changes going to be occurring. It is subject to the continuous stresses are produced. Why the continuous stresses are produced? Because there is a chemical changes in that solid material due to the presence of air or some kinds of gases, and these chemical reactions that occur are due to this one. Chemical reactions are occurring, and that chemical reaction occur are oxidation. In the presence of air or oxygen, materials such as rubber and polyethylene undergo oxidation, giving rise to surface cracks. What happens? Cracks are going to be produced due to the presence of air or oxygen, and the oxidation takes place of just like the material, for example, is rubber and polyethylene. Then at this time, the surface cracks are going to be occurred on the solid dielectrics. Now, second one, hydrolysis. When moisture or water vapor is present on the surface of a solid dielectric, what happens? When moisture or water vapor is present on the surface of solid dielectric, hydrolysis occurs, and the material loses their electrical and mechanical properties. When the material loses its electrical and mechanical property, surely you can say that it can be easily subjected to the breakdown in that material. Because the electrical and mechanical properties are going to be changed, are going to vary, they are going to lose, or they are going to be lost. Electrical properties of the material such as paper, cotton type, and other cellular materials deteriorate very rapidly due to hydrolysis. Just like the plastics like polyethylene undergo changes and their service life considerably reduces. What is the last effect of all this one? Chemical and electrochemical deterioration and breakdown. Their service life is going to be considerably reduces. Their service life considerably reduces due to the chemical and electrochemical deterioration and the breakdown. Now, next one, breakdown due to treeing and tracking. What happened? Tracking, what is the treeing? Tracking, it means the sparking of the spreading of the paths are generated. Due to this path, the breakdown occurs, and this is called as a tree. Sorry, this is called as due to tracking. It means this is called as a tracking. When a solid dielectric subjected to electrical stasis for a long time, hence normally two kinds of visible markings are observed on the dielectric material. They are, first one, the presence of conducting path across the surface of insulation. They are the presence of conducting path across the surface of insulation. And second one, a mechanism whereby leakage current passes through the conducting path finally. What is going to happen? It is going to lead to the formation of the spark. Just what I have told you starting, tracking it means formation of the spark. These are the discussion about 2 or 3 percentage, 4% are discussion that these sparks are how to be produced. What is their presence? So, and when this spreading of the spark is just like a tree, then at this time you can say that it is called as a tree. What is the tree? Spreading of spark channels during tracking in the form of branches of the tree is called as a tree. Both are connected. Tracking, processing of the spark. And what the tree, when they are spread out, and when they are spread out in just like the branches of the trees, then this is called as a tree. Now, next one, breakdown due to internal discharge. What happened? Certain type of solid materials or that one certain type to extend liquid dielectric contain the whites of the cavities. Cavities, we are saying the cavity within the medium at the boundaries between the dielectric and the electric. Dielectric material and the electric. What happened? Cavities are generated or cavities are formed. These whites of the cavities are generally filled with medium of lower dielectric strength. It means what is there now going to be causing? Because there is a lower dielectric strength as compared to the dielectric strength of the medium or the material. So in this case, the dielectric constant of the medium in the white is lower than that of the insulation. Just I have told you that breakdown constant, dielectric constant of medium in the white is lower than that of insulation. Hence, the electrical strength in the white is higher than the across the dielectric. Due to this, what happened? Electric field strength in white is higher than the across the dielectric. Therefore, even under normal working condition, the field in the white may exceed their breakdown value and the breakdown may occur. What happened? Voids and cavities are formed. Due to these cavities and voids are formed, what happened? Even though under normal condition, the field in the voids or in the cavities exceed their breakdown value. You know that everybody has every part or every medium has a breakdown value. If this value is exceeded, then you can say that breakdown occurred in the case of solid dielectric.